So as Karina just announced, I'm going to be presenting a paper together with Rolf van der Velden and Tim House, who are also in this meeting, but also with Babs Jacobs, all colleagues from the Research Center for Education and the Labor Market in Maastricht University. So our paper is called Identifying Literacy and Numeracy Skill Mismatch in OECD Countries Using Job Analysis Method. And I would like to begin by giving you a little overview of what we are going to do. So first, what is skill mismatch? Although I assume most of you already know because you've joined the session, I would still like to mention that skill mismatch happens when the level of skills that a worker has is not equal to the skills that he or she should have to do the job. Being over or underskilled has consequences for the labor market. If you're overskilled, that means that your potential is not really fully exploited, and you normally get lower wage than if you were well matched. Then if you're underskilled, that means that your job is probably not properly fulfilled, and you're likely to face a wage penalty. Given that it's very important, given that skill mismatch has big consequences in the labor market, it's important to have a proper measure for it. Thanks to PIAAC, we have excellent information on the literacy and numeracy skills that workers have, but we don't have that information on the required skill levels in the PIAAC metric. In the literature, there have been proxies, but those proxies often come with weaknesses, as we're going to discuss later on. So our contribution is to develop the job analysis method and apply it to determine the required skill levels in the PIAAC metric. And then we're going to compare our method, job analysis method, with other methodologies that already exist, both in regards of the proportions of skill mismatch, but also on how skill mismatch affects relevant outcomes, such as wage and job satisfaction. So now that you already know a bit what we are going to do, I would like to tell you how. So we're going to start by presenting the different measures of skill mismatch. Then I will develop what exactly the job analysis method is. Then I will go for the data and empirical strategy. After that, I will present the proportions of skill mismatch, then the results for the wage and job satisfaction analysis, and I will end this presentation with a conclusion. Well, now that you know what skill mismatch is, I would like to explain a little bit more the different measures that already exist. First of all, there's the job analysis method, which consists on some sort of normative assessment of skill mismatches, which counts on experts' views on the critical skills, which are assessed directly. So this is not really a proxy. However, everything that has pros also comes with cons. So the job analysis method is very expensive and tends to ignore that there's within occupation heterogeneity. Also, it heavily relies on having up-to-date and relevant information because it's based on existing task descriptions. Other methods that are commonly used in the literature, for example, are the worker self-assessment, which is a subjective assessment. That is, the worker himself or herself says whether they are well matched for the job or not. So it is very easy to apply. It can be at the individual job level, but it also comes with problems as it could be biased, and it could also have reverse causality with some outcomes. For example, depending on your job satisfaction, you might feel that you are well matched or mismatched, and the other way around. We couldn't really know. Then another method that is also very used in the literature is the realized matches approach, which is a statistical measure. Basically, it's a proxy that takes into account the average or the median skill level of the workers that are already there. It is really easy to apply, but it also has a very strong assumption, which is that the average worker is by definition well matched. And it also really ignores within occupation heterogeneity. And finally, another commonly used method is the job requirement approach, which basically takes into account the skill use of the workers. And it's also a proxy, and it's often used in analysis of outcomes. It's also easy to apply. It could also be done at the individual job level, but skill use does not necessarily equal skill requirement, and the skills are difficult to compare with other methods. Well, now that we know that there are different methods and we know, or at least have an overview of the pros and cons of each of these methods, I would like to explain a bit more of what we are doing. So we use the job analysis method to determine the literacy and numeracy required levels for the 4-digit ISCO unit groups. We do 433, so that means we leave out the armed forces. In order to do so, we gather a group of 6 international occupational experts and 2 domain experts, one who's an expert in literacy in PIAAC and the other one who's an expert in numeracy in PIAAC. So this group of experts were asked to rate the critical and current required levels for each of these unit groups for the standard job. So no distinguishing between junior and senior positions. For these, they use mostly the ILO, the ISCO 08 task descriptions. When they were out of date, the experts could update that knowledge with their own expertise. So we use this method to determine the required levels in the PIAAC scale. And besides the levels that already existed in PIAAC, we added in-between levels. So that means when there was a certain occupation that could really not be classified as it requires level 2 or it requires level 3 because it was really in the middle, it got assigned a 2.5. And then certain occupations were really heterogeneous. So we took that into account by assigning combined levels. So that was 3 plus 4, for example. And if you're interested, you could find further information on the technical report that we already published. Then, as I mentioned in the overview, we applied the job analysis method to estimate skill mismatch using PIAAC, and then we're going to compare it to other methodologies that already exist. So to start, I would like to explain the working sample that we use based on PIAAC data. So we focus only on OECD countries because the rating of the occupations was done like having the target population of OECD countries in mind. We exclude Australia due to data protection legislation, and we take a 20% random sample out of the Canadian sample. We also exclude unemployed out of the labor force individuals, people that belong to the armed forces, unpaid family workers, and individuals who declared that their main status was being a student or being an intern, because the relation with wages is a bit less clear in those cases. We also exclude those observations that had missing values for any of the relevant variables, which was only 3.1% of the sample, very low item number response in PIAAC. Then we also excluded observations that only declared their occupation at the 1-digit ISCO major group. And then for the wage analysis, we exclude self-employed and we trim wages per country, the first and the 99th percentile. So now that we have the working sample, how do we estimate skill mismatch? Well, the required proficiency uses the midpoint of the required level as defined by the experts. Also, in line with literature from PIAAC, we don't make a distinction between levels 4 and 5 because level 5 is so high that it's almost unattainable. I think only 1% of PIAAC actually attain level 5. And then we define somebody as being well matched with a range of plus minus 50 points. That is one standard deviation from the midpoint. When we have combined ratings, we just use the full range of both levels. Then we are going to compare the job analysis method with the real-life matches approach and the Pellicer fission. So we are following, for the real-life matches approach, we're following Perry, Wiederhold, and Ackerman-Peak from 2014. So for them, they define the required skill as the average level per country at the 2-digit level. And they consider somebody to be over or underskilled with one standard deviation from the average level per country. Then the Pellicer fission model, they first take into account those that are reported, like self-reported, well-matched. And then they consider that the required skill is the 5 to 95% score range of those that are self-reported well-matched per country at the 1-digit level. They exclude major group 6, and they take major groups 1 and 2 as if they were one group on itself. Then let's say we compare these to these methods as they were done originally, And in the realized matches approach, we also take, well, 2-digit per country as they did, but also 2-digit all countries and 4-digit all countries. However, given the number of observations per occupation and per country, it was not possible to replicate it at the 4-digit level. Here you can see the analysis, like the equations that we use. So first, our dependent variable is the logarithm of wage, and we take into account the required skill proficiency measured in standard deviations, then a dummy for being overskilled, a dummy for being underskilled, and a set of control variables, such as age squared, gender, being like, let's say, the share of self-employed that there were in that occupation, because as a reminder, for the wage analysis, we are excluding self-employed, but they were taken into account when assigning the levels. We also cluster our standard errors by country. Then for the job satisfaction, the explanatory variables are mostly the same. The main difference is that as here we do include self-employed, we add a dummy for being self-employed. First, I would like to present the proportions of skill mismatch. So as you can see, there's quite a difference. So if you look at the job analysis method, around 60% of the individuals are well matched, whereas if you look at Pelletier Fission, is around 85%, and with the realized matches approach is around 75 more or less %. Then naturally the share of underskilled and overskilled are larger when you take into account the job analysis method than if you use Pelletier Fission or the realized matches approach. If we look at the literature, the job analysis method estimates are much closer to the proportions of educational mismatch as measured by Groot and Mas and van der Vink, or also by Quintini. When you take into account the ranking of countries in terms of skill mismatch, so the country that had a very high share of skill mismatch and a very low share of skill mismatch, this ranking varies a lot depending on the measures used. So if you look at correlations, if you focus on the correlation of overskilling, it's very, very low. It's lowest between Pelletier Fission and the realized matches approach at 2 digits per country, minus 0.01. Then when you look at well match, the highest correlation was between job analysis method and realized matches approach, as well as job analysis method and Pelletier Fission, but only 0.55. And then there's a very strong negative correlation comparing overskilling or underskilling proportion between job analysis method and realized matches approach, particularly in numeracy. That means that in numeracy, countries that had a very high share of underskilling in job analysis method had a very low share of underskilling using the realized matches approach. Now we are going to discuss the results. I'm going to start with the wage analysis and numeracy. So as you can see, the explained variance is relatively high and is very similar among each of these methods. The differences between the estimates of the required skill, which are in standard deviations, are like very low. Like all these estimates are very similar. There is a difference when you look at the realized matches approach between 2-digit and 4-digit. That is the one that ignores the country perspective. So that suggests that they might have more noise. But let's say the main difference comes when you look at the estimates for being overskilled or for being underskilled. So when you take a look into the Pelletier Fission model and the realized matches approach, you see that the returns to being overskilled are lower than in the job analysis method. Yes, and what we know from the literature is that the job analysis method is more in line with it, because based on the literature, returns to being overskilled tend to be larger than the penalties of being underskilled, as it happens here, but not in the other methods. When we look at literacy, the conclusions are very, very similar, especially the penalties to being underskilled are particularly high for Pulitzer and Fitchen, but also for the real-age matches approach. But the conclusion holds, job analysis method is more in line with the findings in the literature. When we look at job satisfaction, we can see that the explained variance is quite low for each of these methods. And the effects of the required skill are also very small. If we look at the job analysis method, the effects of being overskilled are not even significant, which hints that the objective skill mismatch might not have an effect on job satisfaction, whereas subjective skill mismatch does, as you can see by Pulitzer and Fitchen. Similar things hold when you look at literacy. Objective skill mismatch does not seem to be very important for job satisfaction, where subjective is. But overall, I would like to conclude by explaining a bit what we've done. We start by saying that the required skill levels are missing in PIAAC, although proxies have been used, which come with weaknesses. We applied the job analysis method to determine the critical current required level for each of the ISCO 08 unit groups. And then we compare it to the real-age matches approach and the Pulitzer and Fitchen. We see that the proportions of skill mismatch vary depending on the method, and job analysis method is mostly aligned with literature. Then when it comes to the wage analysis, the main differences are when we look at the estimates of overskilling and the estimates of underskilling. And once again, job analysis method tends to be a bit more in line with the literature. However, when we look at job satisfaction, we see that objective skill mismatch, such as the job analysis method, does not really have an effect on job satisfaction, whereas subjective skill mismatch does. That being said, the job analysis method, of course, also has its own limitations. So it does not take into account that there is cross-country variation, and it depends on having up-to-date information. So that means it should be up-to-date regularly, which can be very expensive. Nonetheless, even though it has limitations, it also still has important implications for policymaking, given that there are big differences between the different methods. So depending on what your goal is, whether you want to focus on the proportions of skill mismatch, or whether you need to see the effect of skill mismatch on different outcomes, you should choose one method or another. Well, thank you very much for listening for my presentation. And if you have any questions, please go ahead. I'm here, and so are my co-authors. Thank you very much.